Hi, this video will be about molarity. And so molarity, the equation for molarity is moles of solute divided by liters of solution. So sometimes the questions can be straightforward and you'll put the mole, they'll give you the moles and the liters of solute. Sometimes they'll make you determine the moles, sometimes they'll make you determine the liters. So, but pretty much this is the equation you're going to use. All right, so I'm going to go ahead and do some problems here for you. I'm going to start at number 2. I'm not going to use number 1, but number 2 says if a 45.3 grams solution or sample of potassium nitrate is dissolved in enough water to make a 225 ml solution, determine the molar concentration of the potassium nitrate. So remember, I want moles of solute divided by liters of solution. So the liters of solution, let's deal with that first. This is in milliliters, so that means I'm going to take 225 milliliters and I'm going to change that to liters by dividing by 1,000 milliliters and 1 liter and over 1 liter. So I'm going to take 225 divided by 1,000 and that means I'm going to get 0.225 liters. The next thing I need to do is I got to take my 45.3 gram sample of potassium nitrate, which is KNO3, and change that to moles so that I can get the moles of that. And so I need a periodic table. So give me a second. So potassium's mass is 39. All right. 39.1, and nitrogen is 14.01, and 3 oxygens I'm going to add to that, so that's 48, I believe. So this is 101.11 grams of potassium nitrate in 1 mole. All right, so I'm going to take 45.3 divided by 101.11, and oops, something I didn't calculate it, didn't like something I did. 45.3 divided by 101.11. and that's going to give me 0.448 moles. I'm going to keep that because this was 3 sig figs. So again, I'm going to take moles divided by liters of solution. So I'm going to take 0.448 moles divided by 0.225 liters. 0.448 divided by 0.225, and that's going to give me 1.199. And I have 3 sig figs, so that's what I'm going to do, and that's molarity, okay, or moles per liter. All right, so I'm just going to keep going. These next, all 3 of these, okay, are molarity. Okay, so find molarity. All right, again, we're going to do moles of solute over liters of solution, and this time they did give me liters of solution, but they gave me 275 grams. So that means I'm going to change this to moles. So I have to do molar mass. So copper is 63.5 plus 32.06 plus 64. So that's 159.56 grams of CuSO4 in 1 mole. Okay, 275 divided by 159.56, so that's 1.72 moles of copper sulfate. And so again, I'm going to put moles over liters. The liters were in the problem, so 1.72 moles divided by 4.25 liters, and I'm going to get my molarity. 1.72 divided by 4.25, and that gives me 0.404. I'm going to keep the 3 sig figs, so 0.405 molarity. Okay, just keep going. Same type of problem down here. You're going to prepare iodine solution by dissolving 5.15 grams of iodine. Iodine is going to be I2, so that's tricky, so watch that. In enough alcohol to make a volume of 225 milliliters. So you probably guessed it. I'm going to divide that by 1,000 to get it into liters, and that's going to give me 0.225 liters. And I'm going to change this into moles. So 1 mole of iodide is going to be 126.91 times 2. So that's going to be 253.82 grams. So I take 5.15 divided by 253.82, and that gives me 0.019. I'm going to keep 3 sig figs, so there's a 5 here, moles of iodine. So I'm going to take my moles divided by my liters. Okay, 0.0195 divided by 0.225, and that gives me 0.0867 molarity. All right, and so you can see every time I'm pretty much doing similar things. And last one, what final volume would be needed in order to prepare a 0.25 molar solution? All right, so this time they're giving me the molarity, and they want to know the liters down here, or volume, either way, in liters. And then I'm going to have to find the moles up here. So they're going to make me do that again. So 2.5 grams of sodium chloride, chlorine's 23, and sodium's 23 and chlorine's 35.45. So that's 58.45 grams of sodium chloride in 1 mole. Sodium chloride. 0.2 divided by 58.45, and that's going to be 0.08896. So I'm going to only have 2 sig figs, so that's going to be 0.089 grams. Oh, sorry, moles. I just changed it to moles. And so this time I'm going to solve for V. So I'm going to multiply both sides by V. All right. And so then I'm going to get V times 0.25 molar is equal to 0.089 moles. And then I'm going to divide both sides by 0.25. And then V will be equal to 0.089 divided by 0.25. And that's still 2 sig figs, so 0.36 liters of water, or liters of solution is what I need. All right, so I hope that's helpful to help you get back and forth between with molarity. Again, the challenge is going to be sometimes they're going to give you the numbers in grams and make you change to moles. Sometimes they're going to give you the volume in milliliters and make you change to liters. I hope that's helpful.